In this video, let us solve the numerical problems 6. The first question is a new treatment plant installed rapid sand filters after their sedimentation tank. The design loading rate to the filter is 200 meter cube per day per meter square. So this is the load and this is per meter square area of the filter. How much filter surface area should be provided for their design flow rate of 0.5 meter cube per second. If the surface area per filter box is to be limited to 50 meter square, how many filter boxes are required? Okay, so per meter square filter area, it can take load up to 200 meter cube per day, or per 200 meter cube per day we need a meter square filter area. Then if the load is 0.5 meter cube per second, then how much area? So this is 0.5 meter cube per second, we just convert it into days, so which would be 0.5 meter cube per second into 24 into 3600 seconds. For this, how much is required? So that would be surface area required would be equal to this one, 0.5 into 24 into 36,000 divided by 200. So this comes around 216 meters square. So this much area is required. Then we cannot have a single filter with this much area, but each filter should be having 50 meters square. So number of filters would be 216 divided by this 50 meters square. So it should be around 4.32. So since the number of filters can't be a fraction, so we should have the minimum 5 filters. This is the answer. The next question: design 5 slow sand filters from following data. For a town of population 75,000 per capita demand as 135 liters per capita per day. Rate of filtration is 150 liters per hour per meter square. So out of 5 units, 1 unit is to be kept as standby. So which means only 4 filters are running. So whatever the area which we want, that has to be provided by the 4 filters. Assume length to be thrice of the width. Okay. So now we have population 75,000 and per capita demand is 135 liters per capita per day. So average demand would be 75,000 into 135 liters per capita per day. So this would be the average demand. Then we have maximum demand, because the filter should provide maximum demand, so which is 1.8 times the average demand, means 1.8 into 75,000 into 135 liters per day. So this is the maximum demand. Then for this demand, how much filter area is required? So for 150 liters per hour, a meter square area of filter is required. 150 liters per hour per meter square. 150 liters per hour, then meter square area of filter is required. Then this liters per day, 1.8 into 75,000 to 135 liters per day, how much is required? Okay, so this day can be written as 24 hours to make it uniform units. Then this would be 1.8 into 75,000 into 135 divided by 24 into 150. So this should come around 5062.5 meters square. Then this area should be provided by 4 units, because 5 out of 5, 1 unit is standby. So this is to be provided by 4 units. So area of filters should be, each filter should be 5062.5 divided by 4. So this comes around 1265.6 meters square. Then this is the area which is length into breadth. So we have given that length into breadth is 1265.6, but length is thrice the breadth. So this would be 3b square is equal to 1265.6, which implies breadth is equal to square root of roughly 421.87. Breadth should come around 20.5. Then length is thrice breadth, which is roughly 61.6. So this is the solution for problem set 6.